Good afternoon. So my name is Paul Chen. I'm from Huawei Canada Research Lab. So I'm working on the Huawei public cloud services, including PaaS, platform as a service, as well as middleware services. So today's topic, I would like to get you some ideas on how Huawei is working on the public cloud and how leveraging the GridGain and other engines, caching engines in the public cloud environment. Before I start, I just want to see how many people really know about Huawei business in general. I guess, yeah. So I guess it's cell phone, communication devices, telco, appliance, equipments. Yeah, that's true. And now what people don't really know is that Huawei also move on to a public cloud business. So become one of the public cloud provider, like AWS, like Microsoft. Huawei actually started its business recently, just like a couple of years ago, since 2015, but growing so far, so good. And I'd like to give us a little bit introductions on the Huawei public cloud overview and give you some kind of idea what exactly we are building on here. And then we're going to go through a little bit on the caching, data caching services, and how we're using GridGain, for example, and other caching engine in the Huawei public cloud to help our existing public cloud customers. And also going a little bit on the caching engine and use cases, what kind of usage patterns we've been using recently, and also some kind of performance latency data we'd like to share a little bit with others. And of course, when we move on to the cloud, we also facing some challenging. And those challenging is probably all the vendors or cloud services are also having it, but we'd like to go through and with you discuss a little bit more. And some hybrid cloud initiative is we also want to go into it. And really challenging part is that when we're building caching infrastructures, how we can reuse the same caching infrastructures, not only just for public cloud, but we also would like to use the same infrastructure into hybrid cloud as well as the private cloud. So this is also challenging as well. And also additionally, we'd like to go through a little bit on the things to explore, and then maybe open up for the questions. So as I mentioned, Huawei started the public cloud business since 2015, but actually really starting is last year. The reason I'm saying is really starting last year because before it does not really actually have cloud divisions. It's basically the IT division is take over and do some cloud business since 2015, but really not formalize the form a way that can start making business for the cloud as a cloud providers. So really starting in 2017, at the beginning of 2017, Huawei started creating a separate cloud division, which is the goal is to explore and grow on the cloud business, and mainly focusing for the first couple of years is focusing on public clouds. And the approach we did is based on the current solutions that our customers have been working with it before the cloud. And we understand the customers' pain points. We understand their roadmap to go to the cloud and how difficult they are doing on it. So what we do is we, based on the solutions that we've been dealing with the customer before, and we kind of building blocks to building from bottom up to building those services, those categories of services to group them, and we making them to work together, integrate very nicely to solving specific solutions. So those solutions, like we're dealing with 860 solution partners, and come up some kind of very user-friendly way of solution based on those building block services that are building up on there, and to solving some of the customers' issues like smart city, like manufacturing problems, as well as like in the financial banking. They actually are putting some services into public cloud, and they have a pain points that we would like to, solving it for them. So, and also even in e-governments businesses also will be able to building those kind of solutions on top of that to provide it. So it's an open public cloud. Basically means that not only the large company will be able to host it, the small, medium developers, they also can be able to, get instances, grab some services and play with it, running the application on top of it. So similar like AWS is what it does. Now, one of the interesting parts here is that you see it's starting from 2015. It's actually starting from nothing, really from nothing. So we are seeing that at the beginning, we only got about 7 categories and about 18 services to be on the public cloud. So at 2015, maybe not much interesting if you want to go there, and you probably won't be able to do much. But now we're growing. 2018, January, when we do the next last check, we actually double our categories from 7 to 14, and the number of services out there is grow from 18 to more than 100. So basically, it's about 7 to 8 times grow within 3 years, and the quality of the service is getting very, very good, better than the 2015 time. And we building building blocks, basically start from bottom up. We start building all services suitable for integrate with all different layers, including the IS layer, which is infrastructure as services. We actually have very easy to use deploy services that can actually acquire a VM, get a VM, get containers. You can get this storage, and you can even provision entire network, a VPC, for example. And up to pass layer, you can actually acquire an entire application runtime layer that you can actually drop your application onto it and then just run. For example, you can just drop your Java application to runtime, and it will just start the entire container, and your application just running. And also database layer, which is including the relational database, documentation database, new SQL, as we'll be just talking about these days, and also the caching, which is one of the stuff we're going to talk about today. And if you see going up, is a lot of more services is building blocks. Basically, one to each other is related to each other. So you can very much build an entire solution using those set of services. That ends up what you provide is enterprise applications that leveraging all the services, integrate all together seamlessly, and provide a very fast perform and scale public cloud infrastructure for you to run your business. So today we'd like to really go through a little bit more detail, zoom into the database area, which is the caching parts. So data caching service is one of the most fastest services in Huawei Cloud, public cloud. And usually what we found out that when the customers are ordering the database, let's say MySQL service, for example, they usually will actually order services instances for caching as well. The reason is very simple, because the application want performance, and they want to be able to cache, somehow, we're not going to go down to database all the time. So usually it's like 1/3 of the customers, when they're choosing the database service, they're always going to choose the caching services. So a little bit architecture on data caching services architecture. So in Huawei caching services, they're including 2 engines. So 2 engines is actually built inside, which from user point of view, they don't see it. Very, very similar like AWS Elastic Caching. So the one is a GridGain engine. So GridGain enterprise version is as a part of building engine that user actually can get instance for it, and they can bind it into the application and use the caching capability. And the second engine we have is a Redis. Redis is mainly to solving some very simple key value problems. Let's say you actually have a very simple application. You're just using key and value, and you may not dealing with the very fancy, sophisticated use cases that GridGain can handle. You may be able to get a Redis instances to use it and bind it to your application. And from here, you see, from application developers' point of view, when they're dealing with 2 different engines, they do not dealing with 2 different way of managing it, because it's rather as a service and expose the service interface as the same way. Then the user will be able to using some dashboard or using command line to be able to provision a caching instances. And underline, we have a caching service broker, which is a manager to be able to manage a different type of engines. Some particular action may need a handle for GridGain, for example, and during the provisioning time. So we're going to actually understand what kind of engine are the needs to be able to handle that. And then manager will deal with resource scheduler deployments. Basically, that's the component is doing the intelligence behind. It does the scheduling resources to understand the capacity underneath that can be assigned to the request for provisioning, and to be also be able to defragment the resources. For example, if somehow it is just not enough memory, for example, be able to allocate for the new instances, it will be able to predict that case happening and to be able to massage the infrastructure and resources to make free up the spaces so that you can actually add more instances to it. So those is kind of like resource management and scheduling capability that drive the provisioning on the cover. Now underneath, depends on what caching engines users pick, and depends on the application use cases or types. And it will actually be able to provision, GridGain service or Redis services onto either VMs, which it could be a VM resources, and it could be a physical box which is running as a Docker containers, and that will be standard up to be served for that particular applications. And we also have a strong security layer and to handle the instance level security. The GridGain is providing some nice authentication layers that we can actually encapsulate between the different vendors and different service instances owner, so that we don't want to be in trouble that application one may be able to access some cache data from application two. And another, for Redis, because of a lacking of the capability of security, authentication, authorization, ends up we will actually have to take in the open source and to change the code to be able to enable that level of security to make a very similar level of GridGain has handling. But anyway, but that will be transparent from the user when application developer subscribe the instance of data, instance of caching, and it will be available. It will be isolated. Resources will be isolated per tenant, and application user will be able to using whatever the application interfaces to work with the caching. For example, Redis or GridGain's API. And we also enable for JCache interface as well, so that for people who are using the GridGain, their application can actually stay with the JCache. That gives the flexibility to move around between the different caching engine in the future. And also, as I mentioned about resource scheduling, providing a way for managing defragmentation of the resources, and the whole caching infrastructure also is horizontally scale on demand. Basically, when you're ordering a cluster of caching using GridGain or Redis, basically if the caching is round off the memory, for example, capacity, it actually be able to notify, and on demand can be able to, based on SLA, service level agreements that you had, it will be able to automatically grow the number capacity for you for the instances order. So starting from this year, we actually have a beta for GridGain 1.0. And then starting from 2.0, which is just released end of September 30th. So we add a GridGain service as well as the Redis engine improvements together to make a GA. So September 30 is the first GA day for DCS 2.0. We do have customers using both products. It depends on their use cases on the public cloud. And it was very successful in terms of performance for 2.0. So really we see it is is making very fast from provisioning point of view, because before it takes like a little bit less than a minute or two to provision an instance of caching. But now we are actually be able to provision an instance regardless of a GridGain or Redis engine in 8 seconds. And we also, for the runtime, the caching operation performance is 300% times faster than the first version that we had last year. And that mainly is contributing by some optimization we have done from the network layer as well as the hardware layer by leveraging some of the hardware embedded technology to be able to make it really fast. So, and the scale on demand, so is a new feature we actually added in 2.0. Before, we do not really have on demand scale up down. Basically, you will actually have to tell the service provider will actually manually scale up and down for you. But now it's kind of you can actually, based on the usage, it will do that job for you. And also strong security, as I mentioned. So lots of security isolation has been done quite loosely in the last releases, but we're actually doing really good down to make it better. And really, the GridGain has a very good security layer already, so we didn't do much on changes on that. Mainly is focusing to make a Redis engine to be very much the same level, which takes some efforts. Based on these data caching services in Huawei, we actually mainly have a few different use cases. Some use cases we've been using quite a lot now, but some use cases we actually will try to explore. Because lot of cases in public, there are restrictions in public because user cannot really access the server side of the whole infrastructures. So they don't really know what engines underneath is running. But what they only have is a piece of client code using the caching. So that gives us some kind of difficulty to making all different use cases to be applied in the public cloud. But anyway, we start with a very simple way of site cache, as the previous session talking about a site cache. And HP session, replication, we can go through a little bit more. And then we start exploring the change data capturing use cases. And the right behind, right through is a typical data grid use cases, which GridGain play a pretty important role down there. We would like to go in that part as well, and some of the SQL query. So site cache, our stats shows that almost 80% of our current cloud customers, their application is using caching, is using site cache. And one of the reasons is that it's simple, easy, and usually their application already has some kind of pattern, site cache pattern already. So idea is very simple. So they have a caching, they order caching from Huawei, and then they have a database, which usually is from Huawei as well, which is using like MySQL or some relational database. And then the application will using site cache pattern. So look at the caching. If a caching is not, there's no data for the cache, and it go down to the database, grab it, and put back into the cache. And next time when you're asking for the same data, rather than going to database again, you just get grabbed from the cache. So the nice part is that actually remove the database latency as well as the communication latency between the database and the application. So that gave a pretty good performance in overall. So some of our customers using that for what purpose? So these are some use cases we've been looking around it. So a lot of customers using for e-commerce site. So they attribute e-commerce site and all those category, shopping cart, links, all those kind of stuff is cached. So because those are not changing really often. Most is a read most, write less. So in those cases, they put it on there. And the public services, a lot of services, they're providing some kind of information, news, feeds, and they would like to put in there, but changes are not that often. So usually it's perfect for the caching use cases. And some social media, like I mentioned, with feeds, like blogs, and those updates is not that often. And somehow when it's been cached, that usually can be used for quite a long time. Network games, like when play games, some states needs to be cached rather than always get it from the database. And some of our customers are using that pretty heavily to rely on the caching data to understand the location of each game characters on the game console. And the search engine, so it's also, again, because of read most, write less. So somehow it's using those kind of use cases a lot. Now, when we break down to what kind of use cases using GridGain lots and what kind of use cases using the second engine, which is Redis a lot, it depends on. So GridGain is pretty good, and most of Java developers is going to be really deal with the POJO objects. So the class objects serialization they're very familiar with it, and the using Redis is not very convenient. So those customers pretty much is all using GridGain engine in order to do the caching, site cache pattern. Some client would like to using general SQL-like query to look it up, the cached data. And again, the Redis does not provide the general way of lookup and do a SQL-like query. So usually it's not their options to go to Redis. And some transaction control need required. Some application would like to do the put, then you commit it, rather than every time you put, you commit. So in this particular cases, GridGain is one of the choices that they have. And multi-language support. So you write using Java, and you read it from Node.js. So in that cases, You could do in Redis, but you actually have to do some kind of serialization yourself on your end, which is not that good experience. So that use case user will be using the GridGain a lot for that particular cases. Some customers, not a lot, maybe a few, they probably wanted to have their own customizations for serialization. The reason is that some serialization, they may have a performance issue. They wanted to do differently. So in that case, they would like to have their own serialization that can plug in into the environment so that they can actually use that to handle their own data objects. Those is also mostly is using GridGain. But again, lots of customers which are simple ones. Those customers is really not much POJO or very complex objects to deal with it. Usually they do just key value. They usually have, say, oh, I have a catalog in my shopping carts, name of catalog, description. I just want to cache the thing rather than I go back to the database to grab it. And in this case, simple key value pair is good enough. And those customers usually is very much either a very new customer. They are really just start writing those REST level API or a simple key value pair client, and they usually choose that technology. And the other cases is that some customer we had is they're already using Redis. So they've been using Redis client and to talk to the caching already. So in these cases, they usually just stay with that engine instead of the GridGain engine. So that's a very popular side cache pattern. It's about 80% of 70-80% of customers have been using that. HTTP session is another popular one. This is usually used for the web applications, and typical is usually is a website that require user logon, like needed to persist the user sessions, because when you log on, you have a session, and then the session can be reused during the session time. But what's happening here is that there are two ways to put in the session. One is you always put in a database. So every time you grab from database. So that would be a database latency. It's going to be slow. But another option is that you just put it locally on the file system. But every time you just grab from file system, whenever you do the actions. But the problem here by doing this way is, what if you have three instances of all your applications? Each one have a local copy of your session. There's no way you can sync properly. So this is probably not a good idea for it. So lots of our customers, when using the session-based application, web application they build it, they usually put the session into the persistent, a distributed caching site. So they cache the session into a distributed session cache and making all instances of the application available to read from. So the benefits of doing that is very simple. So when one of the stuff die, one of the instances die, and you don't lose the session, you are not going to be forced to log out. Like when you do the online shopping in the middle, suddenly there's one server down, and you're being logged out. You actually have to pick up on your shopping cart again. That's no good. So it ends up, and this is a very popular ones for pretty much like a web application or shopping site, e-commerce site, or something like that. And usually what they do is that they log in the user profile, session, and the user objects, and the shopping cart, and also store category. And sometimes they also cache in the browser history. Let's say when you're shopping around, which part you have been shopping through, it will keep track on the session. So next time when you come back, it will show you all the list and say, oh, you're visiting those products. You wanna see again, something like that. Now, one of the benefits by doing this way from our customer here is that session failover. So if one or more of the instance of applications down, as I mentioned that you don't lose the session, you will still be able to log on. And also, when it's come back, because the session is in the session, not in the database, the warm-up time for this failed server restart, it will be way much faster. So if you have 30 million records sessions to be reloaded into the server from database, it's going to take a very long time. But if all the sessions are still available in the distributed session side, it will be much easier, much faster to warm up this guy again after failover. So this is two use cases really doing it very often. And another use case which is not doing very often, but still have somebody is asking for, some customers is asking for to handle that is a change data capturing. So if you familiar with Oracle has a call IBM has a data capturing product, and Golden Gate is Oracle's product, which is a similar product. What they do is that they be able to detect the changes of the database records. Let's say somebody insert the data into the database. It will be able to call the user exit class to invoke, notify the caching server to invalidate the stale cache. So that mechanism is very important, because otherwise, you're going to probably the data becomes stale. It will be impacting your applications. So this use cases, most of we see is using GridGain cases, but that actually requires some customization. We actually have to work with the customers to make that happen, because that actually not only just client-side changes, but also need to back in. But we're also looking into some possibility of using Redis, which is Redis providing modeling, which is a plugin external model. We can actually plug in that logic to do the similar thing as well. But ideally, we want to encapsulate all those details, but want to present as a single interface into the user, so that user, when dealing with the caching, they don't dealing with all different types of engine. So right behind RightSource is another one which we would like to take advantage on the GridGain, so that we improve it. Current releases 2.0 does not have that capability. The reason is it requires some server side of integration, so that we will be enabled for user to plug in their own server side of implementation, so that they can actually do some kind of right behind RightSource use cases to integrate with the data store or the backend file system. Another one is we would like to explore is really the caching in the Hadoop cases, which not only just do the FDFS, we would like to be able to leverage parallel computations on the server side, on the caching side, to do more calculations on the server side, and then be able to cache the temporary data or results in the cache, so that we can reuse in the different pipelines. So we'll talk about, here's a couple of real customer use cases. So I didn't name those customers because, confidential, but basically, just want to tell you some of the usage we've been doing for the GridGain. This is actually a public service agency. What is their business is that they open public service site, which providing some public service query, news, service catalog, and some other events, as well as the forms that people can acquire and process and submit. And also there's a workflow under the cover to be able to help user or help individual to be able to query their services as well. So there's mainly involved on traffic, like traffic events, traffic accidents, and also some other related events that they had to deal with it. So their website is pretty huge, and ends up, they at the beginning they really required a 50,000 concurrency, and this is keep going, then they found out that when they put the stuff into Huawei public cloud and hook up the database at the back end, they're realizing that it's not perform well. And the reason it's not perform well is because the database bottlenecks, and it just cannot handle that much concurrency. And when it handle that, especially at the peak time, at the daytime, when there's a lot of requests coming from their website and platform, and they just not going response very well, and sometimes even crashed. So that impact on their business very badly. But go on to the public cloud is their strategy. They want to go there, but they found out that there's a bottleneck. So after that what they did is they choose to using the caching. So they got a caching cluster, put it into in front of the application, and then using the infrastructure like the one just joined here, so to be able to handle that concurrency roles. And what ends up is after this changes, they actually be able to perform and concurrency improve 10 times. And even the 50,000 concurrency is the current state, but it's still growing. However, because of our capability of auto grow on demand, so those capacity of the caching clusters can be grow on demand. Basically, even then this is going further, become bigger and bigger in terms of concurrency, we'll still be able to handle it. So far, they'll be able to handle very well, and they are quite happy with the performance. Another use cases we're talking about in here is one of the search engine provider. Again, no, I'm not going to provide a name, but it's actually in Asia, one of the largest, I guess, Asian Pacific engine provider. So it has a huge amount of data, business data to force through into their site. And they actually have to collect, analysis all those data in a minute, every second, not minute, every second. What kind of data they have to processing? News data, social media data, some blogs, some chat groups information, and some online volume. And they're using that data, they pass into their analytics engine and to try to do some predictions. One of the example could be, there's some political changes, they're using all the source coming in, doing some analysis, and find out, it could be have some political changes later on in the next couple of weeks or something. So they have that kind of engine to build it, to be able to help them to analyze the data and to get some good recommendation. Again, because the larger of collected data significantly increase the process and modeling efforts. And their object modeling is become so complicated, and it just takes so long to calculating, to generating a report and sending over. So they do some investigation and found out, there's lots of redundant data. So 1 million of the data coming in, half of them, or maybe not half, maybe 40% of them is actually the same data. Maybe slightly different, but it ends up, in the analysis results shows it's the same data. So how be able to handle that, use the resource to calculate the same data many, many times. So that's a very waste. It's a low performance and a very inefficient. So they're looking into it, and in public cloud, they decided to using caching, and basically it's behind that is a GridGain. So they're using caching is DCS cluster. They're clustering the instances. They have five nodes clusters at the beginning right now, and they put in front of their analysis collectors, which is the Infometrics collecting those all the data feed into their system. And then they're using the caching to filter all those redundancy. And they make sure that the stuff sending after the caching to the messaging system, which is a data messaging system here, is the data which is no redundancy. So that ends up as reduced almost 50% of the data that the analytic engine needs to be analysis and needed to be doing calculations. And then finally, all the data will be feed into the business management platforms to help decision makers to make decisions on what we're going to do under this. So that actually ends up, when they did that, they found out they actually save about 70% of deployment cost, because before they're adding a lot of more power in the analytic engine as well as the business management platforms, but ends up they just need to add a few more caching server and cluster nodes to put a problem in front rather than leave a problem in the later stage, which will cost even more money. So 70% deployment cost saving, and double the data processing time and efficiency. So that's the value they got it. So we're talking about two different engines that we've been using, right? So it's not going to be just two different engines, but we probably wouldn't look into some more stuff plug in. But at the beginning, we're thinking, how are we going to see the differences between the performance latency between these two engines? But again, I wouldn't want to do, apple-to-apple comparison, because they are totally different technology, and it's not fair to, compare, Redis engine with the GridGain engine if its criteria is not exactly the same. So in here, I just want to make sure, if the Redis Labs guys in here don't take a quote on this anyhow, because this is not for comparison. But this will just give you some kind of idea on, what performance result we have, right? Again, the different test tool, we use different test tool to come up. So you cannot say apple to apple. And we're using Yardstick to measure, GridGain from our public cloud. So client is on one system, which is running on one of the instances, and the server, which engine is on another side. So then network through the public cloud network, and we measure using Yardstick. And for Redis, we're not using Yardstick because there's no such plugin. So we're using Mentier. And same thing for caching objects. We don't caching exactly the same objects. So based on the use cases, for GridGain, we're actually using the Java objects, which is sort of like POJO type of objects that we measured. And the Redis is mainly MSET because that's usually our customers been using. So we're doing slightly differently. And also the heap requirements is also different because of Java versus COS. So don't quote on this, but we'll just give you some kind of idea. So configuration is like cluster nodes with a 1 for async replica and 9 million records coming through, and 1K per object on value, and there's about more than 300 connections coming in. So it's a big realistically environment that we want to verify. So as you see, even number of nodes is different. So this guy, GridGain, has 9 nodes, but this guy has 8 nodes. The reason is different because it's just accidentally we actually have 2 different environments set up. We just don't want to do that again. So it's different number of nodes, and ends up. So if you see, replica is similar, and it is about 300 threads concurrency. The heap size, we give a GridGain a little bit more heap because the Java JVM itself needs to be a memory. But again, it's really heap size is not really significantly important in this case because the data we put in is good enough for even 16G. Request is coming in like almost like 9 million requests is coming in, and ends up. So what we got is, so those latency is a combination between get and ports. So it's not just get. Get is faster, right? Get usually you can get less than 1 millisecond, but it's a combination of get ports. So the ratio is about like 80-20. So 80% get, 20% port. So give us some kind of like simulating the real cases in the real life. People using cache usually is read the most, write the less. And so we got a latency about like 2 milliseconds for GridGain, and about 1.5 millisecond for Redis. But again, it's not an apple to apple. And guys, don't quote on this. But in my opinion, is very close in terms of performance what we're looking for. And the performance in terms of TPS is about 95,000 per node. So if you total have 9 nodes, so 95,000 times 9 is about 1 million TPS. And the same thing for Redis, it's about 80, 90. It's very close. So basically from what I see here is that both engine works well, and it really depends on what use cases that you wanted to go for. And if you're really looking for some use cases that require the complicated objects in the Java and some other things that we're just talking about it, GridGain is the way to go. But so simple, just key value pair. Maybe Redis is fine. It doesn't really make too much different for those cases. So challenges. So one of the challenges for us for IMDG is the ecosystem. So our main customers is mainly in Asia Pacific. So Huawei public cloud has about 10 to 12 regions, cloud regions, and there's about more than half is in mainland China. But there's a one in Hong Kong, couple in Singapore, one in Thailand. There's other 2 in Germany somewhere. So basically, you can see the distribution side is really mainly focused on the mainland China as well as Asia Pacific. But now, question here is, so far I'm seeing the in-memory data grid or in-memory computing platform ecosystem is still building up in China. But it's not very mature yet. So a lot of people may be a little bit scared on, technology maybe, pick an easy one. Let's say, just go for Redis, right? But again, they probably wouldn't be able to see a lot of more value when move on to MDG. But I think that takes time to build up. And as I'm seeing that this is building up, it's just a matter of time to getting the ecosystem built up there. And another challenge we're seeing is the enterprise cloud transformation. So we are seeing some customers actually they are carry over from the traditional data center. So their application used to be running in the data center. Then they call us, say, by the way, can I have my stuff running in public cloud? But I don't want to heavily change my applications. Is it possible? And a lot of answers, it's pretty hard because a lot of application, you're gonna actually have to do something, right? But I'm not focusing on the application side yet, but I'm focusing on what about the caching part. So some customer, when they're working on a data center, they actually has caching. They may be using some other cache technology, right? Maybe they're using IBM one, extreme scale, or using HydroCast, or data grid, or GridGain. But again, when they move up into the public cloud, how easily we can transfer them to point to an instance of a new caching services that can provide exactly the same functionality without changing the application. So sometimes you see the challenging because, yeah, Jcaches may be one of the answers, but however, those are traditional applications written like 5-10 years ago. There's no Jcache at the time, so it does have to make some changes. So we do have some kind of customer, hesitate to move on just because of those small little details. And another one is migration across the different cloud providers. So as you probably know that in China there's a few pretty popular cloud providers, right? So it's pretty huge competition between us as well. So a lot of time, when customer move from one cloud provider to another cloud provider, their basic requirements are very simple. I don't want to change anything, just move me. Okay, sure. But point here is how easily we can just say, just move me. It's very easy to say, but it's really hard to do. And underneath, interfaces, management interfaces, for example, can we keep a similar management interface or some kind of tool to migrate that over? Number two is runtime interfaces. Can we have the similar, for example, caching? When application using particular pattern to run the that side cache pattern, when we move into let's say Huawei, can we keep the same without any code changes? This is a very challenge, and we are seeing in some cases we do actually have to work with the customers to make some changes in order for them to move into our cloud. And another thing here that we were talking about is smart caching. So we really don't want people to pick, I want this engine, I want this engine. We really should say, you want a caching. But based on your application and how your application worked and what's your SLA requirements, underlying, we're just going to pick one. So ideally is make caching itself to be smart enough to serve for the application to be more seamlessly integrated to each other and reduce the number of lines of code that the customer has to write in order to using your caching as a part of the caching patterns we just discussed earlier. The last but not least, Huawei optimization. So we actually seeing lots of opportunity these days is to improve the performance of caching from improving optimized hardware. Because there's a lot of hardware innovations going on these days which really help us to make it faster. For example, AWS is using FPGA technology. They claim they actually have 7 times faster when they're putting a main cache D into FPGA and providing as a caching service 7 times faster. Great. AEP, the new generation of TAM that supposed to be maintaining 98-95% of the performance that we have. That's great. So this is something we will look into it to try to making our caching engines perform faster. So other things to explore, as we mentioned that we just really like in a very early stage. So the way that we leveraging both Redis as well as GridGain, are not cover all the features that I have. And we really want to explore something that IMDG technologies provides to improve in a different way in the public clouds. So right behind RightSuite is something we would like to explore more to see how that can actually open up the opportunity that making this caching service is really becomes IMC platform, which is making it as a whole platform, so we can actually supporting all the advanced use cases like a real-time application, like AI cases, like other big data use cases. So those are what we really want to move on, rather than we stay on just pure simple caching services, but just today, but not necessarily to be just tomorrow. And smart caching that we're talking about, HTAP, caching, streaming data, and real-time data analysis. So those is something we would like to focus on next. And the migration, as I mentioned, is difficult, but we still have to handle it because otherwise customer won't move. And AEP, as mentioned, is something also we would like to focus on in the next release as well. So the last page we're talking about here is in-memory computing platform. So this is really what we would like to go for. So this is not today, but we'd like to, hopefully is a very near future, is we really want to build our IMC platform to replace the current data caching as a service. And the engine could be an in-memory data grid on the cover, and the compute nodes, and doing analysis on the fly, and it will be able to pass in the data through, streaming data through that engine to do all the query, in-memory computing, and the result to be sent into messaging, data lake, or even time series database. So that's exactly what we would like to transform. But in the short term, it is okay. We are building blocks, but in the long run, the caching service will really want to go for that directions in our plan. That's pretty much it. Okay, I run out of time. So thank you very much. I guess. Yes? Yeah. So the differentiation between Ali public cloud and us is that we actually have very strong hardware supports and innovations. So for example, we have ARM. We have a LibOS technology, which is actually be able to improve the caching, for example, and software performance from the bottom-up point of view, but rather than just try to make software faster. So we actually have all angles to make our solutions better. Yes.
So what application do you see the benefits of service? What workload do you see?
ARM. ARM is very good on the core. So if you compare with 8632, usually it's a 40 cores, but ARM by default 64 cores. So a lot of application which wants to leveraging the number of cores to make a parallel computation much faster, ARM is a good choice. So for example, let's make a caching example. So Redis is a single thread things, right? It heavily relies on cores. So what if I have 64 instances of Redis running on ARM? It will be way much faster than 64 instances running on 86. Because 86 core is 40. So 64 core running parallel versus 40, it definitely is faster. So it depends on the cases. You will decide which solution you're going to go for it. Any other questions? Okay, thank you very much.